Hi everyone, my name is Nana. Today I'm going to talk about unmanned aircraft system (UAS) in construction. The reason why I want to pick this topic because I'm interested in drone applications in different industries, and also I was majoring in architecture, so I'm specific interested in UAS in construction. So I will go through three main topics here. First one, applications in construction. I will go detail about benefits and challenges on this one. Second, I want to introduce types of UAS in construction. The last one, I want to focus on some UAS technologies used in construction. Applications in construction. There is a wide range of drone applications in construction. This photo shows one of the most common applications of drones in the building construction. It is a progressive monitoring, or you can call building monitoring. Here is a table to show the areas of applications in the industry. The first three are progressive monitoring, site planning, and site mapping and surveying. I'm actually surprised the drones get already involved in each step of building constructions. Start from site planning, then simulation and inspections. I remember when I was an undergraduate student, we needed to go to site and work a couple blocks and then measure the site by ourselves. But now, I think you can just stand on the site and use drone to draw out everything for you, which is much easier right now. There's some benefits. Some I just mentioned. Here are more. Time saving. UAS can quickly catch data from large or hard-to-reach areas, especially for those sites serving, inspection, and monitoring. I think cost saving is one of the biggest benefits. Lower the operation cost of the UAS compared with the traditional mass, result in overall cost saving in projects. Usually traditional mass is like using human to do the work. And all those work is really take a lot of times. Another advantage is improved safety. Because some place, like I said, it is kind of a dangerous area for people to go. So UAS help to mitigate the safety risk on construction sites, reduce the accidents as well. Here is a case study showed on the article. The team group built this called SD model to simulate the performance of UAS-based safety inspections. The model includes 28 factors influencing safety inspections. So we all know that construction industry has higher rate of incidents and fatalities. So that is the wide group did this research. And then they think making safety management and accident prevention is very important. The study conducted scenario analysis for the 4 cases: safety inspection, incidents, fatigue, and amount of delayed work. The results showed improved safety inspection performance, reduced the incidence rates, decreased the worker fatigue, and reduced the work delays with the increase in frequency of UAS usage. Here, these graphics show the data generated by their team. So we can see when drone used frequently, the safety inspection performance is increased and the incidence is decreased, as well as the fatigue also is decreased. The study verified that UAS-based safety inspection can be more effective than existing methods. However, nothing is perfect. There are some challenges when they use drone in construction. Weather really affect the UAS operations, such as strong winds, rain, poor visibility, which can compromise the flight performance and the data collection. Second, confined spaces. Operating UAS in tight space can be complex because there are buildings, trees in surrounding environment. Third one are technical issues. On the article, it mentioned the team member need to handle issues like signal loss, battery limitations, or some sensor errors. The quality of photo can be reduced with close take photos as well. So I think all these challenges, people who work in this industry are trying to solve or improve in the future. Move to next topic. There are two types of drone using in construction. They all have their own features and functions. Here the image, fixed wing drones and rotary drones. I show the image to let us better understand what they look like. And also from the design, we can kind of tell why they play different role in the construction. Here is a comparison between both. Fixed wings have a higher speed and a longer duration of flying. They also have a simple structure and easy to maintain. They're used to map and serve large construction sites. However, they do need to require runway for takeoff and landing, which may limit some construction environments. And also they are less maneuverable than rotary wing. Rotary wing drone can hover, take off, and land vertically. But I think this image, left one, bottom one, they have a propeller on the top. So even this is the fixed wing drones, but it still can hover as well. Anyway, rotary wings drone have a highly maneuverable and suitable for various construction applications. So they can operate in smaller space and are more capable of flying in complex environment with obstacles as well. Rotary wings, it's common one in the construction application nowadays. Last one, I want to talk about some technologies used in construction. First, visual and thermal cameras. Visual cameras are used to collect regular images, videos, and thermal camera or thermographic cameras that sense infrared radiation, collect radiation with longer wavelengths than visible light. The purpose of using thermal cameras, it can identify the cause of water damage or energy efficiency. So on the left bottom image here, they use the thermal camera and it detects the water on the bottom floor and also the top of ceiling. LiDARs and laser scanner. By utilizing a line of laser beams, it is possible to catch the surface forms of objects or buildings. This technique is used to create digital 3D representation of objects. These technologies were deployed for the post-disaster building damage assessment. The UAS LiDAR system has potential for civil engineering and construction projects, particularly for tasks such as excavation and bulk pile measurements. And here also brought in the photo to show how they using laser scan, utilizing a line of the laser beams to capture the surface of form and the form of the building, and then create this kind of 3D image over here. Here is another case study that using those technologies in the construction. This study involved a JI Phantom 4 model, which is this guy here, and the equipment with this 20.4 MP camera and GPS, which can catch of geo reference images. They use visual cameras and GPS to catch some photos and then generate 3D models of construction sites. Using drones for construction progress has a lot of benefits. UAS allow for the rapid documentation of worker in the progress by catching 100 or 1,000 of photographs from different angles quickly. This data collection is really efficient, so it gives a more accurate and complete picture of the construction site. Using the UAS facilitates the monitoring of hard-to-reach or large-size outdoor area, which would be time-consuming and potentially unsafe for manual inspection. So this case using drone with the building information modeling, which we call BIM, and this 360 cameras give a completed view of both indoor and outdoor construction. It makes progress reports more accurate and helping with the better decision making. So this technology gives detailed visual data without needing much human involvement, which is a very big improvement for construction monitoring. Move to next. There are 3 UAS flying types. They're autonomous, semi-autonomous, and manual. So first one, autonomous, how it works. So it completed by connecting GPS to flight planning software or by using pre-established GPS waypoint. It usually completely run on the computers with built-in autonomy. And for this one, the pilot operating is the least demanding manner. Autonomous UAS are used in construction like building and bridge inspection, progress monitoring, urban planning. Second one, semi-autonomous UAS. Combine human and computer autonomy, allowing for manual intervention when it's needed. So this approach is benefit in complex, confined space where fully autonomy may be challenging. But also the article mentioned the semi-autonomous control is uncommon use, with only a few studies adopting this approach. The last one, manual. Manual control requires a human pilot to operate the UAS without computer autonomy. So this method is used when autonomous capability are not available or in the situation where precise manual control is needed, such as near the buildings or in the space with limited GPS coverage. Benefits of manual control include the ability to make quick decisions and judgments during the flight, but also it requires skilled pilots it is more labor intensive. When I talk about this, it actually reminded me discussion from a couple of weeks ago. We are discussed about the autonomous cars, the level of autonomy. So from no driving automation to full self-driving capacity. It's very similarly. Here is all my reference. If you are interested in this topic, you can read them. Thank you for your time. Thank you for watching and listen. Please feel free to leave your comments on our discussion board. See you next time.